Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome to the Innovation and Organizational Development Laboratory. After you have watched the video about the 5 stages of design thinking, we are going to work on the case study. In this case study, we are going to discuss about the application of design thinking to a company, namely e-fishery. The application of design thinking is carried out through 5 stages, namely emphasize, define, ideate, prototype, and test.
Gibran's life journey started when he experienced the bitter of hunger, which prompted him to choose education in agriculture in the hope of reducing the problem of hunger in Indonesia. While taking an aquaculture course, he was inspired to try his luck in the world of fish farming, starting by renting a fish pond in Bojong Soang. Even though his first harvest reached 130 kilograms, he faced problems with excess stock which required him to sell with low margins. Responding to this situation, Gibran founded Dori Food Indonesia to process catfish. Over time, he developed the fish farming aspect and had a total of 76 ponds when he graduated from college. However, Gibran saw a problem in feeding fish. A lot of feed is wasted, eliminating nutrients and polluting the environment. This is what prompted him to establish e-fishery, a solution to increase feeding efficiency and reduce the environmental impact of fish farming.
After knowing the problems that are being faced by Gibran, we can then work on the problems that he is facing as a goal by entering them into the objective table named Designing an Integrated Aquaculture Ecosystem from Upstream to Downstream in order to create a continuous production cycle. We can then directly analyze it into the needs to do, pain, and gain table by directly answering the problems or concerns experienced by Gibran as a fish farmer. Firstly, we have to determine the needs to do in the form of problems that Gibran is experiencing or he already experienced as a fish farmer. The problems that Gibran is currently experiencing is apparently related to the provision of the fish food which has not been carried out as scheduled, so that a lot of fish food is wasted. From this problem, we can answer the needs to do table that Gibran wants fish feeding to be done automatically as scheduled so that it is optimal. Hence, the difficulties or obstacles experienced by Gibran turned out to be due to the fact that the amount of food received by the fish was less than the needs of the fish itself, which could eventually inhibit its growth, resulting in a lesser optimum harvest results. After that, we can determine the gain. Gain itself means a desired output that has not been achieved and will be achieved when the problems are solved. Determination of gain is based on what has been filled in the pain table. In the previous column, when the obstacle in providing insufficient fish food, which has an impact on optimal harvest, has been resolved, then the gain or desire regarding fish growth will be more uniform and optimal can be achieved. This method also applies to the following tables regarding need to do, pain, and gain. After understanding the emphasize stage, we will proceed to the define stage. The define stage is the stage of determining the problems to be solved through the information collected in the previous stage. For example, in our case study, fish and shrimp cultivation requires a new way to meet the demands and needs of fish farmers regarding automatic feeding at the emphasize stage. After that, the define stage is carried out by identifying various elements that can answer your questions by positioning themselves as users. So, from the results of the problems obtained at the emphasize stage, it can be concluded that there is no technology that is able to regulate feeding automatically in the cultivation process, so that it influences less than optimal harvest result. Therefore, in the next stage, we will carry out trials using the 4 tables in the define stage, namely the user, needs, insight, and how might we tables. For the first table, namely the user table, for this table we can enter who directly experiences the problem. Namely, in this case, there are fish and shrimp farmers. Then, the needs table contains the main problems faced by fish and shrimp farmers that they want to solve, namely, use of technology to increase the productivity of fishery products. Then the insight table contains what will be obtained when the results of the problem is resolved. In this case study, fish and shrimp cultivation methods will be obtained with technology. After going through the define stage, the next stage is ideate. This stage is carried out through brainstorming sessions using creativity and innovation to obtain ideas that have the potential to be developed into a solution. The ideas generated must also fulfill the three elements of design thinking, namely humans, technology, and the economy. The idea for e-fishery feeder came from the experience of e-fishery feeder CEO Gibran Huzaifa regarding the challenges of fish and shrimp farmers in managing feed and utilizing technology. In the case study of e-fishery company, the selection of ideas was carried out using the bingo selection method and resulted in an idea in the form of creating an e-fishery feeder product. Gibran Huzaifa invited Krishna Aditya to develop the e-fishery feeder product, which is Internet of Things or IoT, based on automatic fish feeder product that can be programmed via a smartphone application. In addition to the feeding function, the e-fishery feeder application can help farmers optimize profits through saving and efficiency of feed and cultivation services from preparation to sale and cultivated products. The prototype stage is the stage where we'll change ideas into physical form so that users can later interact with these ideas. The aim of carrying out this stage is to produce improvements and evaluations of problems encountered in the product. In the e-fishery feeder case study, the initial prototype of the e-fishery feeder product was designed using aluminum tube material equipped with a feed thrower and meter made of acrylic. The design is then turned into a block shape made of sheet steel and polymer produced via 3D printing. This design continued to undergo changes in shape and material until it produced the first prototype, which is ready for mass production in 2016, by combining plastic and acrylic as its constituent materials. Plastic material was chosen because it is easy to maintain, durable, and it is rust-free. In the following years, e-fishery feeder adjusted the shape of the storage tube as well as the feed thrower and meter until obtaining the final design in 2019. Apart from the prototype in the form of a product design, there is also an application prototype that displays several interfaces for the features offered by e-fishery feeder. This application has three integrated services, namely e-fishery farm, e-fishery mall, and e-fishery fresh, which allows users to control and record fish and shrimp feeding via smartphone, study the cultivation process, plan harvesting, view cultivation results reports, and purchase cultivation needs such as feed, medicine, and vitamins. The final stage carried out in the design thinking method is testing. In this phase, testing is carried out to find out whether the prototype or idea that is made is in accordance with the wishes of the user and to find out how much the benefits or uses of the idea that have been made are. For example, in the creation of the e-fishery application, testing was carried out through three types of methods, namely filling out questionnaires, product testing, and interviewing product users. Testing via questionnaires was carried out on 357 fish and shrimp farmers in Java and Sumatra. The result was that 48.46% or 173 cultivators stated that digital technology had an important role in the operational process of developing fish and shrimp cultivation businesses. Most cultivators consider technology to be a positive thing and an important factor in cultivation. Direct product testing shows that in 2021, e-fisheries revenue has increased 8 times from the previous year. This increase shows that the use of e-fishery has succeeded in optimizing farmers' income through optimizing feed and providing various service facilities. In line with the two previous test methods, fish and shrimp farmers in the Java and Kalimantan regions stated that the use of e-fishery feeder allows capital savings and feed efficiency of up to 10%. Apart from that, the feed conversion ratio or FCR, which is the ratio of the amount of given to the weight of the fish produced, can be reduced by up to 0.4 FCR. Farmers also stated that e-fishery feeder can handle the spread of the infectious myonecrosis virus, IMNV, virus outbreak which can cause premature death in shrimp. This will certainly have an impact on increasing profits from fish and shrimp farming that apply e-fishery feeder. That's all the design thinking case study at the e-fishery company. I hope you can understand what is being said and can implement what you have been taught. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.